All right, folks, it's Bass Action, back in action here. On this page of notes, we're going to do a quick review of our formulas for midpoint distance and slope, all of which we've either done this year or you did in your Algebra 1 classes. We're also going to practice calculating those, and then most importantly, at the bottom of the video, we're going to talk about writing equations of lines specifically with point-slope form. Lots of students didn't use that in their Algebra 1 classes, so I want to make sure you're really familiar with it. All right, so let's jump in here at the top, midpoint. We did this at the beginning of the year. Remember, if we're going to write that formula, we're going to just add those x values together and divide by 2, and we're going to add those y values together and divide by 2. It doesn't matter what order you call the point 1 or point 2. Most importantly, what I want you to be thinking about is I really just want you to think about average when we're thinking midpoint. You're just averaging the x's, averaging the y's. On our distance formula, we have this great big square root, and this is where we typically write it x sub 2 minus x sub 1, and then we square it. And we typically write y sub 2 minus y sub 1, and then we square it. Remember, it doesn't really matter which point you call point 1 and which point you call point 2. What matters is that you're consistent. And then the other thing is that we talked a lot about the fact that the distance formula is closely connected to the Pythagorean theorem. So if you can visualize a right triangle in the coordinate plane, that will help you a lot. Now let's talk about slope. We haven't talked about slope yet this year, so we're going to talk about slope. Again, we have this y sub 2 minus y sub 1 idea here. So we've got the 2 minus the 1, and then x2 minus x sub 1. Again, doesn't matter which point you call point 1 and which point you call point 2. What matters is this consistency for what you're working with your numerator and denominator. Also remember that slope is the rise over run, so it's the change in the y values over the change in the x values. All right, next let's talk about parallel and perpendicular lines. So parallel lines will have the same slope. Perpendicular lines will have the opposite reciprocal slopes, which means they have to be different signs and the fractions have to be flipped over. Horizontal lines have a zero slope. They're flat, they have a zero slope, and vertical lines have an undefined slope. It's very important that you use that language of undefined for a vertical line, because if you just tell me none, I will not count that, because I don't know if none is talking about undefined or if none is talking about zero. So very, very important, that vocabulary. Let's look at a couple examples, and I am going through this very quickly, so if slope was something hard for you, you might need to pause this and reflect on these calculations a little bit more, but I am going through this one very quickly. All right, looking at example 1a here, calculating this slope, I'm going to remember rise over run, so I'm going to work with my x or my y values first. I'm going to choose to do the 7 minus 3 just because that keeps my numbers positive. So I have a 7 minus 3, and then I'll have my 9 minus my 2. That gives me a 4 over a 7. So that's the slope of the line that I've been given, and then the line parallel to that will have the exact same slope. The perpendicular line, though, will have the opposite sign, so we're going to make it negative, and then we're going to flip the fraction over for the opposite reciprocal. Let's look at our next one. Again, got to focus on the y values first. On this one, I'm going to again choose to do, I'm going to start with the negative 3. So I'm going to do my negative 3 minus my negative 1. So I'm going to write that immediately as a plus 1. And then I'm going to do my 5 minus my 2. So now I'm going to have a negative 2 over a 3. That's the slope of the line passing through those 2 points. So the slope of the parallel line will be exactly the same. The slope of the perpendicular line will now be positive, and I'm going to flip it over. Next one we're going to look at, let's focus on those y values first. Doesn't matter which one I start with, so I'm going to say a negative 4 minus a negative 4 is a negative 4 plus 4. Now I'm going to do 5 minus 3. So I get a 0 in the numerator and a 2 in the denominator. So if you're not sure on this, what this simplifies to, you can type it in your calculator. You could plot those 2 points, and what you'll find is that they are horizontal with each other. So this is going to simplify to a 0, which means the slope of the parallel line also has a 0 slope, but the perpendicular line is undefined. And we need to write that word. We can't write 2 over 0 because that doesn't mathematically work for us. Looking at our next one, grab those y values. I'm going to do a 4 minus 1 because that keeps it positive for me. And now I'm going to do a -5 minus the -5, or -5 plus 5. So now I have a 3 over a 0. So we have to stop again and think, what does this actually simplify to? If you plotted those points, you'd see it's a vertical line, and of course we know vertical lines are undefined, which means the slope of the parallel line is also undefined, but the perpendicular line will be 0. Okay. Last thing I want to talk about is writing equations of lines. Now, the one that you typically worked with the most, probably in your Algebra 1 class, was this slope-intercept form. And although that's nice for graphing, that's not the one that we're going to focus on. So what we want to remember on this, inside this box in the top line, is that to write the equation of any line, we need to have a point and a slope. And in your Algebra 1 classes, you tended to focus on that point being specifically the y-intercept, which is why in this form, what you typically did was the m was our slope and the b was the y-intercept. It's pretty rare, though, that we're actually given the y-intercept, so we need to work with a better form, a more useful and flexible form for us, and that more useful, flexible form is going to be this point-slope form. This form of a line is crucial for us when we're in your Algebra 2 classes and your pre-calculus classes. So we're going to start working with this now to get ourselves very comfortable with it. The m still means the same thing. The m is still slope. That hasn't changed. But this time, what we're going to do is we have this x sub 1 and this y sub 1, and that's not just a y-intercept. It is any point on the line. So this makes this a much more flexible and useful form for us. So let's just take a look at 2 simple little examples on how we can use this form and how easy this one works for us. So if on this problem I want a line that's going to be parallel to the one I'm given, that means that the slope that I want to be using, oops, I tend to do that all the time, sorry guys. The slope that I want to be using is going to be the same as the slope of the line that I'm given, so it's going to be a -3. And then all I give you is this random point that it goes through. So when we set up our point-slope form, we're going to do y minus our y coordinate, so a y plus a 5, because y minus the -5, and then the -3, and then I'm going to do an x minus 2. Cleaning this up, I'm going to do a -3x plus a 6, and now I'm going to move this 5 to the other side, and I'm going to write a -5. So my final answer is -3x plus 1. Now, I know a lot of you, what you learned to do was work with this one and find the b value. I can't explain why, but the number of students that get this wrong when they try to use that technique is overwhelming. So I'm just telling you, this form is not only a little more useful for us, it tends to have fewer errors, even though it looks more complicated, and you need to know how to use it for your future math classes. Okay, so on to our next one. This time we want our line to be perpendicular to our given line. So if we want it to be perpendicular, we're going to think our perpendicular slope is going to be that opposite reciprocal, so it's going to be 3/2. So now, setting this up again, I'm going to say y minus 4, that's that y coordinate, 3/2, and an x minus a 6. So when I start working through this, I'm going to have my 3/2 x, and when I distribute this 3/2 to the 6, what I'm thinking is 2 goes into 6 3 times, and then 3 times 3 is 9. So I'm going to have a y, 3/2 x minus 9, and then I'm going to add that 4 from the other side. So my final answer is 3/2 x minus 5. Okay, so that's all that I need you to be able to be comfortable with. You've got that worksheet that I passed out in class. So if you already did that and you didn't work with the point slope form, make sure that you do practice that because we're going to be using it a lot in class.